Hello everybody, this is Michael. In this video, we will do the one key module simulation. So from previous video, we have done the coding for the one key mod, okay? So it's time for the simulation. We create the file, and we copy the common information for the trace. So this is one key mod simulation. It's test bench. Okay. So we save it. We save it into this folder. So this is one key mod TB. Save. Okay. So the first thing, of course, is a module. The module. Okay, module name and the port. So this module is the one key mod test bench, and this port is we don't have any input or output. Okay. Next, we need to define the time scale for the simulation. Okay. After this, we will define the clock period. We define the clock period. The clock period. So it's 20 nanoseconds, which is 50 megahertz. Okay. And then after that, we need to create the test target. So this is one key mod. This is our test target. Okay, so this is our test target. We create the test component's name is one key mod, and we change the okay. So here, this is input parameter. You can just do the input parameter like this, or we do the things like this. It's more readable. Okay. Reset in. And this is key on. This is key off. This is GPIO. Key GPIO. Okay. So next we need to define the interface signal. For the input signal, of course, we all divide it like the register. Okay, register clock and register reset. For the output, we divide it like the while type. Key on, and key off. Okay. So for the key GPIO is also input. So we divide it like the register value. Okay. So next we need to create the clock. We need to create the clock. For the clock, we have a standard code like this. Initial the clock as 1. Initial the clock as 1, and then we use one always block to create it. So delay for half clock period. So period This is need half of it. And after the half of the clock period, we reverse the clock level. So this is a standard clock generate code. It's very simple and easy. So because this one defined is 20 nanosecond, so half of it is 10, and reverse it, so the clock will be 50 megahertz, okay, which match our crystal on our board, okay. So next we will create the simulation test flow. Initial begin. What we need to simulation is the debounce, okay, the bouncing of the code. So which is here. We need to first we need to initialize it as high level, and then we bouncing it and change it low level and change it high level, low level, high level, and then keep it like the low level always. Keep the low level. Keep it as low level always, and then bouncing it again, high level, low level, high level, low level, and then keep it high level. So we needed to simulate the processing. Okay. Okay. Let's take a look how we simulate it. So the first things, we reset, make the reset system, make the reset signal as 1 to reset the system first. Okay. To reset the system first, and we also, when the system reset, you see here the GPIO input is high level is 1, so key GPIO input, it will be 1, okay, it will be 1. So this is the initial state. This is the initial state. After 1 clock period, okay, we need after 1 clock period. So this is half of it. We make it 1 clock period, and then we finish the reset. Make it high level. When it is high level, so finish the reset. Okay. So here, before this, here we finish the reset. After this, we will simulation the debouncing, the bouncing here. How we simulation the bouncing? We just simply change the level of the key GPIO. So after 1 clock period, we change this one as 0, Okay, so like this, we make it as 0, and then 1 clock make it as high. Okay, so after 1 clock, we make it as 1 high level at this position, and we make it low level 1 high level again. So we copy this one. Okay, so this is low level, this is high level, and then we will make it as 0 low level, 0 low level. So we finish bouncing. Here we finish our bouncing. And then we delay for 10 clock for 100 clock period for this done. Okay, we clock delay for 100 clock period. We copy this one first, make here, and this is 100. Okay, so the 100 is for the down state. Okay, after this, after the down state, we need to simulate the bouncing again. Okay, so copy this one and save this. We simulate the bouncing again. The initial state, initial level for the GPIO here is 0. So we do something. We copy it 0, 1, 0, 1, and then do some more. Do some more bouncing here. And finally, here it need to be high level. So means here this state. Okay, so this should be high level. After this, we finish bouncing. Finish bouncing. Okay, so we need to do the clock delay, 100 clock delay, to keep the high level for 100 clock delay. Okay, after this one, we will stop the simulation. Okay, we will stop the simulation. So this is simulation for the one key module. Here we simulate the bouncing at this position, and here we simulation bouncing at this position. Okay, we can edit more bouncing here. But finally, for the first bounce, it need to keep the low level for the key. GPIO key should be low level. For the second bounce, the GPIO key should be high level. Okay, to match this position and this position. Okay, so this is the coding for the test bench for the one key module. Okay, one key module. So this is one key module, and this is the one key module test bench. Okay, so this is one key module test bench. So let's create our model sim software. Let's create our model sim project to see is correct or not. Okay, so our code is here, and we create our model sim one key module. The project model sim project is one key module. Click it. Okay, we copy this path. Okay, so next let me open my model sim software. Model sim software is here. Model sim software. Okay, my model sim software is here, and let me new one project. Close the current project, and the project name is one key module. Okay, this is for one key module. The project location is this path, here, and we click OK. So it will generate some file here. And we added existing file. We added existing file up. We choose these two files. Click open. Click OK. Click close. And then we compile it to see whether there is some error or not. Okay, it has two errors here. We double click here and we can see, okay, this line is line 63 is here. Okay, we didn't added the missing unexpected. Okay, so we needed to edit the symbol here. Here, we save it. And this is 79. 79 is here. And for this one, we change a little bit like this. It will be better. And else here begin copy. Okay, so this is for reset, this is for system correct running. Okay, so we save it and then compile it again to see. Okay, there is no any problem anymore. There is no any problem. And then we do the simulation. I save it again and then compile. Okay, no any error. And then we do the simulation. Start simulation. We click the work. Click one key more, test bench. It opens a simulation interface. Okay, so we added our signal in the region and we set in the timer. This one should be good enough, and then we run it. It will stop in the code here. It's running. Okay, it stopped in the code here. And we go back to the waveform, click here, move it. And we click here, zoom through. Okay. Zoom through. So you will see here we didn't generate the key on and key off signal. We didn't generate the key on and the key off signal. So let's see what happened in the code and why it didn't generate the signal. Okay. Okay. So here you can see we didn't generate the key on signal. And we didn't generate the key off signal. It should have one clock pulse here and one clock pulse here. So why is that problem? And when we face this issue, how we debug it? Okay, so let's take a look how we debug it. So The first things, let's check our status machine. The first things, let's check the status, so see whether we change the status or not. And we also need to check the negative edge is changed or not, because if we change the status, this one, it should be changed. Okay, so we added two modules. We added two variables. Click here, and we added the state signal to the wave, and also we added the negative edge to the wave. Okay, and here, so we reset the system, and then run it again. Okay, stop here in the wave. Okay, you will see here the state is always 0, 0, 1, and it didn't change during the whole simulation. And the negative edge is always low level. It didn't change at all. So means the negative edge should have some problem. And then let's take a look at the code. So for the negative edge, this is the negative edge. For the negative edge, it decided by the R3 and R2. So let's put the R3 and R2 in the waveform also. Click here. So this is R1, R2, R3 added to the wave. Okay. Oh, you will see here R1 is changed according to, because R3, R1, R2, R3 is all shifted through the GPIO input. The 3 value should change according to the GPIO input. Okay, the R1, R2 is changed, R1, R2 is changed, and shift 1 bit. But the R3 didn't change it. So the problem is R3. Okay, the problem is the R3. Okay, so let's take a look at the R3. The R3 is here. You will see when we do the coding that this R3 should change to R2. Okay, so this is the problem. So we save it. We save it and click the project. Click here. Click here and click this one, and we compile it all. Compile all. Okay, so there is no error. Pass the compile, and then we restart the simulation, and we do the simulation again. Right. Okay. Stop here. Okay, you see here now the R3 has changed, and also we get the 1 clock pulse on the key on. Is this one clock pulse on the key on, and 1 clock pulse on the key off. So it means the code is correct. Okay, means the code is correct. 1 pulse here, 1 pulse here. We get the key on and key off signal. Okay. So this is one key module simulation, and through the simulation we learn how to debug the code, and fix the problem. Okay. So this is this video. I'm Michael, and see you next time.